In this video, we'll learn about isosceles triangles. You should already know that an isosceles triangle is a triangle with at least two congruent sides. In this video, we'll learn a bunch of other special qualities about isosceles triangles. One thing I want to point out is that this part of the definition is very important, where it says a triangle with at least two congruent sides is isosceles. So, if we think about what that means, a triangle with two or three sides could be classified that are congruent, could be classified as isosceles. So equilateral triangles are triangles that have exactly three sides that are congruent. So you can have an isosceles triangle which is also an equilateral triangle, but not always. So if you have an isosceles triangle and the third side is congruent to the other two sides, it's going to be equilateral. If you have an equilateral triangle, that is always going to be an isosceles triangle, because by definition, equilateral means that you have three congruent sides. So if it has three congruent sides, that falls under the umbrella at least two congruent sides. So therefore, isosceles triangles are sometimes equilateral. Equilateral are always isosceles triangles. Quickly, look at this picture right here as I talk about some of the anatomy of an isosceles triangle. The legs are the two sides that are congruent. So, if you have an equilateral triangle, just pick any two of the sides to be your legs. The base is the other side that's not congruent to the two other sides. And again, if the triangle is equilateral, then any side could be your base. The base angles are the angles opposite the sides that are congruent, or the base angles are always opposite the legs. And the vertex angle is always opposite the base. So you can look at it as you got the base, which is parallel to the bottom of the page. Your two legs are the two congruent sides. The base angles are the two angles touching the base. And the vertex angle is the side opposite the base. So, the first thing you want to know about an isosceles triangle is that if a triangle is isosceles, then the base angles are congruent. So if we look at this isosceles triangle conjecture right here, and we adjust it so that these two sides are always equal to each other. AB and AC. So I can move A up. I can move A up so that AB and AC are both very long, and that they're still congruent. If you look over at the side, they're both approximately 7 centimeters. The angles will always equal each other, angle B and angle C. And if we drop A down low, we'll see that even if A is obtuse, it's kind of, I don't know why it's rotating like this, but even if A is obtuse, as long as AB and AC are equal, ABC, angle ABC, or angle B, and angle ACB, or angle C, will always be equal to each other. So, if a triangle is isosceles, then the base angles are congruent. So, let's use that conjecture to help us find out what angle 2 is. So if we look at this picture, we have two isosceles triangles. So we know two sets of base angles have to be congruent. These two angles have to be congruent, and these two angles right here have to be congruent because of vertical angles. And then this angle and this angle, the base angles of the isosceles triangle, have to be congruent. So if this angle is 47, this angle has to be 47 as well, because it's one of the base angles. And then this angle has to be 47 because it's a vertical angle with 47 degrees. And this other base angle has to be 47 degrees because it is a base angle and the other base angle is 47. And we know, since the triangle is isosceles, by these two congruent marks right here, that they have to be equal. So angle 2 is going to be equal to 180 minus 47 minus 47. And you get that angle 2 has to be 86 degrees for all three of these angles to add up to 180. So that was one application of the isosceles triangle conjecture. And like we know, with any conditional statement, it can have a converse. So think to yourself, if the isosceles triangle conjecture is, if a triangle is isosceles, then its base angles need to be congruent. Think of what the converse would be. So pause the video, think to yourself, and then hit play when you want to see the answer. So the converse would be you switch the hypothesis and conclusion. So the converse would be if a triangle has two congruent angles, then it's an isosceles triangle. So we sort of looked at that already in the last Geometer Sketchpad, so I won't waste your time with that. But pretty much, if you know that two sides of a triangle are congruent, then the two angles opposite those sides are congruent. And likewise, if you know two angles are congruent, then the two sides opposite those angles are going to be congruent. So since this fact down here says that angle B and angle C are congruent, so since we know this is true, we know that side AB, the side opposite angle C, has to equal side AC, the side opposite angle B. So what we'll do is, to find x, set those two sides equal to each other. So 21x plus 83 is equal to 3x minus 7. And now we're going to solve for x by subtracting 3x on both sides and also subtracting 83 on both sides. Oops. And I get 18x equals, when I add 83 minus 83 cancel out, and 3x minus 3x cancel out, and then negative 7 minus 83 adds up to negative 90. So when I divide both sides by 18, x is equal to negative 5. And if you were to plug that back in, you would get that the two sides would be equal. Now, let's move on. Oops, this is really annoying. And quickly talk about altitude. So the altitude is a line segment that starts at the vertex of a triangle and is perpendicular to the base. So when you think altitude, think height. So like in an acute triangle, the altitude, if we're drawing it from this vertex, would come straight down and be perpendicular to the base. And if you look, that first line that I drew, this altitude right here, would represent the height of that triangle. But if I had an obtuse triangle, the altitude could also, so I'll draw this altitude in orange, the altitude could sometimes come outside the triangle if your triangle is incongruent. If your triangle is obtuse, the altitude from one of the angles might be outside the triangle. Because again, you're measuring the height of the triangle. Alright, the next thing that I want to say is the median. So the median of a triangle connects the vertex of a triangle to the midpoint of the opposite segment. So if we draw an acute triangle over here, we would first find the midpoints. So let's say that's the midpoint of that side, that's the midpoint of that side, and this is the midpoint of this side. The median from this vertex would just come from this vertex and hit the midpoint of the opposite side. So that would be one example of a median. This would be another example of a median, coming from the vertex to the midpoint of the opposite side. And then this would be another example of a median, coming from the vertex to the midpoint of the opposite side. And obtuse triangles, it would sort of look the same. We would find the midpoint of all the sides and connect one vertex to one of those midpoints. So here is just one example of a median in an obtuse triangle. The reason why I go over that is because medians, altitudes, and angle bisectors have special properties in an isosceles triangle. And that is, and this does not always work for all triangles, in an isosceles triangle, the bisector of the vertex angle is also the altitude and the median of the base. So again, if I were to have a triangle, If I were to have a triangle that was isosceles, so I'll draw it as best as I can right here. Both these sides are equal. And if I drew the angle bisector, it would cut right down the middle of this triangle because these two angles that I'm marking off are equal. Alright, so I'll draw the angle bisector in blue. Now if I draw the median, well, if I find the midpoint of the opposite side, it would be right around here. And if I connected the vertex and that midpoint, I would have the median. And notice how it overlaps perfectly with the angle bisector. And then the altitude, I could draw that in yellow. That would start at the vertex and be perpendicular to the base. So for it to be perpendicular to the base, I would have to come straight down. And again, you should see that the altitude overlaps with the median and the angle bisector. So if a question deals with an isosceles triangle and you have either a bisector, an altitude, or a median drawn, you could, if it says that it's one of those things, you can assume any of the properties of the other two things. So for example, right here I have an angle bisector. I know that because I have that these two angles right here are marked off as congruent. And I also know it's an isosceles triangle because these two sides are congruent. Now just knowing that this line that I'm highlighting in blue is an angle bisector is not enough for me to know that 12 is equal to 2x minus 12, because angle bisectors do not necessarily hit the midpoint of the opposite side. Alright, that's only true in isosceles triangles. But since I know this is an isosceles triangle, then I could set 12 equal to 2x minus 12, because since it's an isosceles triangle and that's an angle bisector, I also know that the angle bisector would also be the median, which connects one vertex to the midpoint of the opposite side. So that's why I'm allowed to do that. And to just give you a little counterexample before I solve this problem, I'm going to draw an obtuse triangle up here. And I'm going to approximate what the angle bisector would look like, cutting this angle in half. Alright, and notice how it would definitely not hit the midpoint of that opposite side. So the angle bisector is also going to be the median if you're dealing with an isosceles triangle. So here would be a counterexample, or an example to help further that point. So let's solve for x. I'm going to add 12 to both sides, so I get 2x is equal to 24, and I'm going to divide both sides by 2, and I get x is equal to 12. And if you plug that back in, you would get that those two sides are equal. I believe that's all I have to say. Yep, that's all I have to say about isosceles triangles. Thank you for watching. I hope this video was helpful, and have a good one. 12 minutes exactly.